Okay, so let's look at SDL sound library, and let's go ahead and get this into place and have it working. So what I did is I chose a classical piece and based this off of the sound. Because I have a bajillion of these opened up. Alright, so right here we have our violin minuet. I'm not going to pronounce that, I think it's Italian. But and this is the wave file I'm playing. And here you can see the number of hertz that this file is for the wave. And then we have the number of kilobits in size, and the 16-bit stereo, and it's going to be 2 channels, and it's going to be a duration of 58 seconds. And total size is 9.78 megabytes. Okay, so from there, we'll switch back over here. Let's have a look at our sound system now. Okay, so here's our audio specs. We have an audio spec here. It's going to be spec desired, spec obtained, and spec wave. This is because, let me put it this way. You put in what you want, and then what you get is another thing. You can make it get pretty much, it'll do its best to pretty much give you what you asked for. We'll even emulate the hardware if need be, but it does a very good job of that. So I wouldn't worry too much about that, but it is good to know what it is you got back, and not necessarily what you put in is what you get back, because you know the hardware, you may ask for something the hardware can't do, or you may ask for something it's not compatible with the hardware, and instead of having to code out for every basically every sound card known to man, this takes care of it for us. So this lets us put in basically what we want, and then if the hardware can do it, then we get back what we wanted pretty much. If it can't, then it'll do its best to emulate it or something like that and still make it happen. So it'd have to be a really bad situation for it to not play it, in which case there's always compatibility requirements for a game or some software package. So that's nothing new, and it's to be expected. SDL_audio spec here, spec wave, and this gets into the actual specification for the wave file that can be played, and we will be playing a wave file. Okay, we're going to do a struct here, SDL_audio stream, and yeah, this is going to be the basically the audio stream that we're going to play here for the sound, because we're going to actually have to stream the music byte by byte. So kind of sucks, but that's the way it is. Pointer to current sound data. So this could be our unsigned int 8 here for current sound, and then our current sound length. It's just going to be an int, and then unsigned int 8 for 8-bit be the next sound, and then int next sound length. All right. Close curly brace, semicolon. Awesome. SDL audio stream here, and then we're going to have our wave data here of unsigned int 8 wave buffer, unsigned int 32 wave length. And so this sets up our audio stream that we're going to have for streaming to the sound card. Because essentially what we do is stream it byte by byte to the actual hardware of the sound card. Okay, and then this is our wave buffer, because we have to have a buffer that we store our bytes in that we are streaming, and then here's the wavelength for the length of the actual sound file, if you will. SDL audio CB, or callback, and this is the callback function here. Go ahead and prototyping it. I should have done this with all my functions, honestly, so that way it doesn't matter what order you put your functions in if you prototype it like this, by declaring it at the top. And if you declare it up the top like this, declare your functions, then no matter what order you put it in, it will find it and work for the code. So this is a great catch-all. Just let you know ahead of time what functions are going to be involved in the program. This lets someone quickly find if there's a function that's missing or something they're looking for in the program by having them listed at the top. And then the other thing about it is, again, the order of the functions no longer matter if you do that. Otherwise, if you have to have something defined before you call it, of course, normally. This supersedes that, where you don't have to worry about that anymore once you have this in here. So it's really actually quite good, and I have that one for the audio, but I really should have done that for the other functions. All the other functions in this program should be like, I don't know how many functions, quite a bit of functions at this point in time. Okay, so with that, let's go on further here. Scrolling. Got lots of code now. We're still going. Here we go. Alright, so I put the audio callback here before the CD. So functions, it honestly doesn't matter which one you put first, but anyways, here it is. Void SDL audio CB for the callback. You'll see CB used a lot for callback. Sometimes people will actually spell it callback. Either way is cool. I don't care. But if you do see CB in a function, typically for a name of function, typically CB stands for callback. Unless you're talking about a GUI interface, then it may be combo box or something like that. But typically you see CB is callback though. So SDL audio CB for callback, and I'm going to do void star here user data comma unsigned int uint8 star buffer comma int len for length. Close parentheses, open curly brace here, SDL underscore audio stream star p stream here. So this is a pointer to our stream of data. Semicolon, that's why it's called p stream. So p stream here equals open parentheses. I'll space that out a bit because that's a little too jumbled. SDL audio stream star here user data. This is our prototyping. That's not a function, that's prototyping it. Casting the value so it gets converted from user data into the proper data type into this here. Okay, so with that, continue while length is greater than 0 and at least one sound is non-empty. Okay, while len is greater than 0 and p stream current length is greater than 0, or p stream next sound length is greater than 0, then we do this here. So essentially if we have a sound that's greater than nothing then we need to do this while loop here. So if p stream here current sound length is 0 equals 0, and then we have copy the next sound to the current sound. So we have p stream here current sound equals p stream next sound. So that way basically switch to the next sound. Now we only have one sound loaded in here, so basically it's going to make our sound loop. So after it's done playing, it's going to go play it again right afterwards. P stream current sound length here, p stream again, next sound length. So we're switching out the current length with the next length. So that way we can switch out different sounds. In this case it's going to be the same because it's going to be the same file. P stream next sound equals null. P stream next sound length equals 0. Space those out again. That's ugly. Alright. While length is greater than 0, the current sound is greater than 0. So if the length is greater than 0 and the current sound length is greater than 0, then stream a byte of audio buffer. Okay. So stream a byte to the audio buffer. So we're going to be grabbing a byte and basically passing that byte over to if we space this out, passing that byte byte by byte actually to the audio buffer here and over to our hardware, and then we're going to decrease our length of our sound here. So this is going to just decrement it for our length, so the length becomes less and less as we play through the sound file. P stream here current sound length, decrement it, so it's less and less for the sound length. And this makes sense because this is why we're checking against 0. So basically once we reach the end of the sound file, it'll be 0 for the length. in which case, and the current length will be 0. And then so, you know, then we're good to reset it. Okay. And that covers that part. And this is a post decrement here. So this is going to be evaluated after the fact, but it doesn't really matter because of the stealing statement on the line, so it's not going to make a difference one way or the other. Void start audio system, open curly brace here. Spec desired equals new audio spec. Spec obtained equals new audio spec here, because we're declaring memory on the fly here at runtime, which means we will have to delete this memory later on when we're done with the application to free it back up. And then we have our SDL audio spec. So set up the audio stream to point to nothing. So we want our audio stream to point to nothing. That's why it's null. And our length, of course, is going to be 0, and then null again, and length 0, of course. So audio stream.current sound is equal to nothing. Current sound length is 0. Next sound is going to be null, and the next sound length is going to be 0. And then we'll set it to something here. So the desired sound spec, audio spec that we want, is going to be 44,100. And where did that come from? Okay, well, it came from right here. See, 44,100. Okay, let's look at else. What else is happening here? Our audio. Let me just break this up too. Our audio format here is going to be audio S16, and that works out very well for us because why? Because it's 16-bit audio. Let me show you that too. Check it out, 16-bit audio. So the S is signed 16-bit audio. Now there's lots of different ones you could have here. For instance, that could be unsigned. You could also have leased here. You can have LSB, which is cool. So this is your little indent version, and then your MSB is going to be your big indent one, and then your system, depending on the system, this might be either the little indent or big indent one here. So this could be either this one or that one, just depending on the system. And then there's also audio U8 too, besides the U16. So that's different possibilities over here. Now if we look at S here, here's all the different S possibilities too. So that was unsigned, here signed. So it's the same thing, only it's signed. And so you can see the difference. Right here I need S16 for this particular setup. And I believe the rest of the files for the most part on that site or this type of layout is going to be the same thing. I did find the best sample size was 4096. So I recommend you set your sample sizes to 4096, and the number of channels should be 2. It could be 1, 2, or 4, but 2 is what ended up working the best for me. And 2 channels for the audio, for breaking it up. You can have 4. This is 2-bit stereo. I mean, this is 2 channels would be 16-bit mono stereo. Or you can have mono. 4 is supposed to be 16-bit stereo, but even though that is 16-bit stereo, putting it at 4 really didn't work. And when we look at the SDL mixer, it says 2 is 16-bit stereo. So I'll have to wonder if 2 is just not 16-bit stereo, not mono. But we'll see. And then 8-bit is stereo too, so it'd be 1 for the channel for that. Or it could be, 2 could be 8-bit stereo for 2 there, and then 1 could be 8-bit mono format for your channels. So it has to be either 1, 2, or 4. It can't be a 3. 3 is not compatible. You will get an error if you try to do that. Alright, and then we're going to do to callback. We're going to say what our callback function is. It's going to be SDL audio CB. So this stores it as our callback function that can be executed later on as needed. So this is really cool. This way we're dynamically storing what our function is at runtime that is going to be used for our callback. And literally in a program you could literally switch out what function is actually going to get called for a callback in this manner. So very cool, and that's a really neat method of doing this. Okay, and then desired user data. So here we have our user data. Here's our audio stream. Okay, so it's an audio stream. as you would expect. And we set up our audio stream up here, and so everything's set up as we would like in the proper format. Okay, so with that, let's move on down. This is another possible configuration here, dealing with the 8-bit sound set up here. Let's comment it out. If SDL open audio here, open parentheses spec desired, comma spec obtained, close parentheses greater than, is less than 0, then we're going to have an error. This would be -1. Standard error, could not open audio device. Delete spec desired, delete spec obtained, so we free our memory. And then exit with 1. Otherwise, we're good to go, and we just need to get rid of our spec desired, because spec obtained is the only one that actually matters. So we have everything now stored in spec obtained after we ran this. So this is the desired spec that we were passing in. This is what we wanted, and this is what we got back, and this is passed back as a reference pointer, if you will. So it gets stored back into the memory after, for what's obtained, gets stored into this one automatically and is returned from this function. Okay. So this frees up memory, so we're not sitting there with the spec desired just sitting around in memory doing nothing anymore. There's no need for it. We got what we obtained, what actually is going to happen, so that's the one we need to use. Okay, so let's load our wave file here. Spec wave equals SDL underscore load wave. And as this is another wave file that I tested this with. Load wave here, violin underscore minuet underscore not going to pronounce it, dot wave, close quotes here, comma, and spec wave, comma, and wave buffer and wave length. And this is going to let you load in that sound, the wave sound that we want. And it's going to automatically put it into our wave buffer and our wave length. It's going to fill in those values for our spec wave. Okay. And this is all going to be equal back to the spec wave, of course. Okay, so our SDL audio lock, we need to lock our audio so that no other, so nothing else is using our audio device, because otherwise we'll have a conflict with the hardware. We had more than one program trying to access the audio system. That'd be a problem. Audio stream dot current sound, so we don't want another part of the program accessing the sound system too, hardware. Audio stream dot current sound equals wave buffer. So we're going to get the data from the wave buffer to play it, and the wave length. All right, and then we're going to do audio unlock thereafter, and then SDL pause audio open close parentheses with a 0 is going to turn off the pause state of the sound buffer. Okay. Now we need to play our audio system. So SDL lock, if stream dot next sound equals null, then we're going to do what? We're going to go to our stream next sound here. We're going to do our wave buffer and set our wave length as such, and then we're going to unlock our audio, and that's going to let us play our audio, more or less, because we're going to let stream the audio to our setup here. So as long as we're streaming it, we're good to go. Okay, stop audio. Okay, we need to stop the whole audio system, which we're going to close it out. So we're going to do our fprintf to let us all know that we're closing it. Here's going to close the actual audio system here with the SDL close audio, open close parentheses, and we're going to delete our spec obtain, our spec wave, and that's the only ones left. Remember, spec desired was already deleted, so this closes out the rest here. And then we're going to free our wave buffer so we don't have that sitting around in memory anymore either. So SDL underscore free wave buff. Alright, so we're going to start our audio system here. I decided to put it right there. Start audio system, open close parentheses, semicolon. And then I decided to play the audio system. And then I forgot to close the audio system. Oops. Created the function, just forgot to close it. Alright, hold on 1 second. And then yeah, we need to stop the audio system. It's kind of important. Not kind of, it's really important. Yeah, so make sure you do that. Otherwise, not cool. Alright. So we are, stop the audio system there at the end. That's pretty much it. I'll go ahead and play it again. And there is Minuet. And it sounds beautiful. Violin solo. Alright, so I'll go ahead and close that, kill it, and there we are. Well, hopefully that was pretty informative, and that's basically how the audio system works, and the different audio types you can have for your different data types, and how you basically get something going and working. And remember, to play it, we don't have just like a simple play, we actually have to stream the data byte by byte into it. When we get over to the mixer, that's really going to solve a lot of problems for us, because it's going to allow us to do all kinds of awesome functionality, and really takes the whole audio system in SDL to a whole nother level and makes a full-blown robust audio system that you would use in an actual application. This is too streamlined and too stripped down to where it's not hardly usable. But in the next video, when we do the SDL mixer, that will basically replace this sound system here, but it's not going to actually replace the SDL audio system. It actually extends the SDL audio system and makes it really awesome. So basically that's what we're going to use next. Okay, so with that, this was SDL Audio. My name is Nate Nessler, and this is for Hyperactive Studios. Thank you very much.